Welcome to March 23rd's LeetCode Challenge. Broken Calculator. There's a broken calculator that has an integer start value on its display initially. In one operation, you can multiply the number on the display by 2 or subtract 1 from the number on display. Given two integers, start value and target, return the minimum number of operations needed to display target on the calculator. So in example number 1, we have a start value of 2 and a target value of 3. So what we want to do is basically multiply by 2 and then subtract 1. So we need to do both one time in that order. So the output is 2, being 2 operations we need to perform. Use double operation, then decrement by the operation by 1. So we get 2 times 2 equals 4, 4 minus 1 equals 3. Similarly, or another example would be start value 5 and target being 8. So what we do is minus 1 from 5, which is 4, multiplied by 2, which would be 8. Alright, and we want to find the most minimum number of operations. Well, another reasonable operation could have been multiply 5 by 2, which is 10, minus 1, which would be 3 operations, which wouldn't be the most minimum, but it'll still work. Start value of 3. So what you want to do is use a double times 2 times 3. Double would be 3 would be 6, minus 1 times 2 again. So it'll be double, decrement, double, as mentioned here, to get 10. X and Y, or in this case, I guess start and target values are between 0 to 10 to the 9. Alright, and that's pretty much the idea. And approach to the solution. A solution to this question would be using the greedy approach algorithm. So what we're going to do is set a number of operations or steps we could take. So let's call that each minimum number of operations we could need to display would be to the target on the calculator. Be a step. So we're going to find a step that we need to take. So each step is an operation. So while target is greater than the start value, what we're going to do is what we're going to do is go from the target backwards initially to and then each time we go backwards and try to get closer to the number, we are going to return the number of steps. So if the target is greater than the start value, what we're going to do is divide it by 2, or take the modulus of that. By 2 equal to 0. So we know that we have to use the double type, the double operation. That means we have to take the target and divide it by 2. And that's going to be there. Else, if it's not divisible by 2, then what we do is decrement by 1. Increment by 1, I should say. Because we subtract 1 and we do the opposite of that, that will be plus 1. And every time we do an operation, either a doubling or division in this case, or a decrement or minus, what we need to do is increment the step that we take to do it by 1. And then we need to increment the step outside the loop as well, such that we are getting the start value minus target value. And that is it. So what we want to do is return the target, return a step, I should say, and we're going to make that an integer because we're returning a number, and it's going to be step. Let's see how this goes. It should work. No. Start value. So time complexity is big O of n, because we will cycle through each element in target such greater than start value. So this is basically working backwards to find the target value. Big O actually is big O log target value. And space complexity is big O of constant space because we were just turning a number. Alright, that is all. Have a good day, guys. Oh, wait, no, we should submit it. There you go. Have a good day, guys.